have a dream that one day
Hi there everyone, welcome to the fourth and last lesson on Surds. In this lesson, we want to look at two more standard techniques for Surds, namely order of magnitude and solving equations. So example 4 here deals with order of magnitude, and it says without using a calculator, write down the following from smallest to largest, and we are given these three surds. Now we're going to use the law that says the nth root of a to the m equals a to the m over n. So we have the square root of 8, then the cube root of 9, then the fourth root of 17. Now we're going to use this law to write all these surds, or all three surds, in exponential form. So the square root of 8 will be 8 to the 1 over 2. So 8 to the half. The cube root of 9 will be 9 to the 1 over 3. And the fourth root of 17 will be 17 to the 1 over 4. Now, our next step will be to look at all the powers, all these fractions in the powers, or as powers, and find the LCD of these fractions. So the number that all the denominators can go into. In this case, it's 12. So we're going to write 8 to the half as 8, and the power will have a denominator of 12. Then 9 to the power of, and once again the denominator in the power will be 12, and 17 the same. So 2 into 12, 6 times the numerator is 6. So a half is the same as 6 over 12. 3 into 12, 4 times the numerator here, which is 4. So a third is 4 over 12. And 4 into 12 thrice times 1 is 3. Now we're going to work backwards. We're going to write these numbers once again as surds. So these numbers that are in exponential form, we're going to write as surds again. So 8 to the 6 over 12 is the 12th root of 8 to the 6th. This is going to be the 12th root of 9 to the 4. And this is going to be the 12th root of 17 cubed. Now, the question says without using a calculator, but we are allowed to use a calculator to do the arithmetic with. So we want to see what it comes to under the surds. So let's do that. So 8 to the 6 is 262,144. So 262,144, and it's the 12th root of this number. Then we also have the 12th root of 9 to the 4. So 9 to the 4, 6561. So 6561. And the 12th root of 17 cubed, So 17 to the power 3. 4913. So 4913. Now we can compare the numbers under the surds. Now the question said, right from smallest to largest. The smallest number under these surds is 4913, and that was the fourth root of 17. So then the fourth root of 17 will be the smallest number. That's going to be less than, and the next smallest number is 6561 under the surd, and that came from the cube root of 9. So the cube root of 9 is the next smallest, and of course the largest number under the 12th root is 262144, and that came from the square root of 8. So let's look at your answers to this question. In the first one, we have the fifth root of 7, then the cube root of 5, and the square root of 2. Now, we're going to use the law that says the nth root of a to the m equals a to the m over n to convert these surds to exponents. So in the first one, the fifth root of 7, it's 7 to the 1 over 5. Then it's 5 to the 1 over 3, and 2 to the 1 over 2. We look at all the powers, the fractions in the powers, and we find the LCD. So the LCD in this case, well, it will be the number that all the denominators can divide into. So in this case, it's going to be 30. So 5 into 30, 6 times 1. 3 into 30, 10 times 1. And then over here, we have 2 into 30, 15 times 1. We're going to use this law again to go back to the surd form. So it's going to be the 30th root of 7 to the 6th, the 30th root of 5 to the 10, and the 30th root of 2 to the 15. Let's use a calculator here. So 7 to the power of 6, 117,649. Then we want 5 to the 10. So 5 to the power of 10. 9765625. And then we want 2 to the 15. So 2 to the 15. 32768. So 32768. Now the question says, right from largest to smallest. So clearly the largest number under the surd is this one, and this comes from the cube root of 5. So then we have the cube root of 5, which is larger than the second largest number under the surd is this one, 117,649. And that came from the fifth root of 7. And then the smallest one will be this number here, 32,768. And it came from the square root of 2. So the cube root of 5 is greater than the fifth root of 7, which is greater than the square root of 2. So looking at the second question here, it says, without a calculator, prove that the following is true, that the cube root of 3 is greater than the square root of 2. So we have the cube root of 3 and we have the square root of 2. Now we can write these in exponential form. The cube root of 3 is 3 to the 1 over 3. And the square root of 2 is 2 to the 1 over 2. Now we look at the fractions in the powers and we find the LCD. In this case, the LCD is 6. So we have 6 as an LCD. 3 into 6 twice times 1 is 2. So 2 over 6 is the same as 1 over 3. And here we have 6 in the denominator. 2 into 6 thrice times 1, which is 3. Now we convert back to surd form. So it's the sixth root of 3 squared. And here we have the sixth root of 2 cubed. And this, of course, is the sixth root of 9. So the sixth root of 9. And this is the sixth root of 8. Now, since 9 is greater than 8, so since 9 is greater than 8, the sixth root of 9 will be greater than the sixth root of 8. And hence, the sixth root of 9 was given by the cube root of 3. So hence, the cube root of 3 is greater than the square root of 2. So example 5 on surds deals with solving surd equations, and it says solve each of the following equations, and we are given these 4. So let's look at the first one. We have the square root of 2x plus 3 less x equals 0. Now, we always want to isolate the surd on the left-hand side, so we're going to take the negative x to the right-hand side. Now we want to get rid of the surd here, so we square both sides. So squaring both sides. And when we square surd, it falls away. So we're left with 2x plus 3 equals x squared. And now bringing everything to one side, x squared minus 2x minus 3 equals 0. Now we can factorize. So x minus 3 times x plus 1 equals 0. And we can solve for x. X will equal 3 or x will equal negative 1. We don't stop here. Whenever we square both sides of an equation to get a solution, we need to test the solutions. So we can first test x equals 3. So we check for x equals 3, and we do so by plugging 3 back into the original equation. So it's going to be the left-hand side will equal the square root of 2x plus 3. In other words, 2 times 3 plus 3 minus x. So in other words, minus 3. And this is going to be 6 plus 3. So 6 plus 3, which is 9, under the square root. And the square root of 9 is 3. So it's going to be 3 minus 3, which of course is 0. And as you can see, it's equal to the right-hand side. So this equals the right-hand side. So we know that x equals 3 is a solution to the original equation. Now we can check the second solution. And the second solution was x equals negative 1. So we check x equals negative 1. And once again, we plug into the left-hand side of the original equation. So it's going to be, we had 2x plus 3 under the square root. So the square root of 2 times negative 1 plus 3. Then we had minus x. So it's going to be minus negative 1. In this case, we get the square root of negative 2 plus 3, which is the square root of 1. And here we're going to get minus, a minus times a minus is a plus, so we get plus 1. The square root of 1 is 1, plus 1 is 2. And we can see that the right-hand side was 0, so 2 doesn't equal the right-hand side. And hence we can conclude that x equals 3 only. So in number 2, we have a surd on both sides of the equation. So we have the square root of 4p minus 9 equals twice the square root of p minus 1. We could bring the surd on the right-hand side also to the left-hand side, but it's going to make it a little bit more complicated. So we start off by squaring both sides. Now, just remember that a plus b all squared. So when we square binomial, it's a first term squared, this sign, so plus, then it's the first term times the second term times 2. In other words, 2ab, then plus b squared. Now, this we're going to apply on the right-hand side here. So on the left-hand side, when we square the surd, it drops. So we have 4p minus 9. And then applying the squaring of a binomial on the right-hand side, it's a first term squared, so it's 2 squared, which is 4, times the square root of p squared, which is just p. Then it's a first term times the second term times 2, with this sign. So 2 root p times 1 is 2 root p, times 2 will give us 4 root p. And then the second term squared will give us plus 1. Now we can take the term containing the surd to the left-hand side. So it's 4 times square root p. And we can take everything to the other side, to the right-hand side. Of course, the 4p's cancel here. So we'll have plus 1, plus 9, which is plus 10. We want to get rid of the surd now, so we square both sides. So squaring both sides again. And 4 squared is 16. The square root of p squared, of course, is just p. And 100, or rather 10 squared is 100. And we find that P equals 100 over 16. We can simplify this. 4 into 100, of course, 25 times. And into 16, 4 times. So P equals 25 over 4. We can check our answer by plugging this back into the original equation. So then the left-hand side will equal the square root of 4p minus 9. So the square root of 4p, which is 25 over 4, minus 9. The 4's cancel here, and we're going to get the square root of 25 minus 9. In other words, the square root of 16, which is 4. Then going to the right-hand side. So checking the right-hand side. The right-hand side, of course, is twice the square root of p minus 1. So twice the square root of 25 over 4 minus 1. And the square root of 25 over 4 is 5 over 2. And the 2's cancel here. And we're left with 5 minus 1, which is 4. So we see that the left-hand side equals the right-hand side. And hence, the value of P, which is 25 over 4, is a valid answer. So P will equal 25 over 4. Let's solve the third equation. We have 6 over the square root of p minus 1 minus twice the square root of p minus 1 equals 1. We can start by getting rid of the fraction here by multiplying through by the LCD, which is the square root of p minus 1. Then the square root of p minus 1 in the first term will cancel, and we are left with 6. Then we have twice the square root of p minus 1 times the square root of p minus 1 is just p minus 1. And of course here we are using the third law. The square root of a times the square root of a is just a. Then on the right hand side we have 1 times the square root of p minus 1. So the square root of p minus 1. We can simplify the left hand side. So it's 6 minus 2p plus 2. Then adding like terms on the left hand side, we get 8 minus 2p. Now we can get rid of the square root on the right hand side by squaring both sides. Then squaring out the left hand side, we have 64, in other words the first term squared, minus 8 times 2p times 2 is 32p, plus the second term squared, which is 4p squared. And on the right hand side the square root drops, so it's just p minus 1. We can bring everything to the left hand side. So negative 32p minus p is negative 33p, and 64 plus 1 is 65. Now we have a trinomial in p, and we can factorize. We could of course use the quadratic formula here as well. So 4p times p gives us 4p squared, and 13 times 5 will give 65, and we need 2 minuses. A minus times a minus will give a plus. And solving for p, p will equal 13 over 4 or 5. Now we need to check both our answers by plugging it back into the original equation. So let's first check p equals 13 over 4. Then the left-hand side of the original equation will equal, now we have 6 over the square root of p minus 1 minus twice the square root of p minus 1. And we replace the p with 13 over 4. So 6 over the square root of 13 over 4 minus 1 minus twice the square root of 13 over 4 minus 1. We could do this on a calculator. Here in the denominator we're going to get the square root of 9 over 4. And here as well. And the square root of 9 over 4 is 3 over 2. So we're left with 6 times 2 over 3 minus twice 3 over 2. And 6 times 2/3 is 4. 2 times 3 over 2 is 3. And 4 minus 3 is 1. So this equals the right-hand side of the original equation. And hence p equals 13 over 4 is a valid answer. Let's now check p equals 5. So once again substituting into the left-hand side of the original equation, we have 6 over the square root of 5 minus 1, so p minus 1, minus twice the square root of 5 minus 1. And 5 minus 1 is 4, the square root of which is 2. So 6 over 2 minus twice 2, 5 minus 1 being 4, and then square root it. And this is 3 minus 4, which is equal to negative 1. Now, the right-hand side of the original equation is 1. So this is not equal to the right-hand side. And hence p equals 5 is not a valid answer. So then the final answer will be p equals 13 over 4 only. Let's solve the last equation here. We're first going to simplify the term on the right-hand side by using the laws of Surds. So we have the square root of 2x plus 3. Then we have 2 square root 2 minus square root 50 over the square root of 18. Now, the square root of 50, we can simplify. The largest perfect square into 50 is 25, and it goes twice. So, the square root of 50 can be written as the square root of 25 times 2, which is a square root of 25 times the square root of 2, which is 5 square root 2. So we have 2 root 2 minus 5 root 2 in the numerator, and in the denominator the square root of 18 we can write as a square root of 9 times 2, which is a square root of 9 times the square root of 2, and this equals 3 root 2. So that's in a denominator. And we also still have an x. So simplifying the term on the right-hand side further, two root 2 minus 5 root 2 is minus 3 root 2. And these factors will cancel, and we're left with negative x. So we have the square root of 2x plus 3 equals negative x. Now we can get rid of the square root on the left-hand side by squaring both sides. Then on the left-hand side, the square root drops. And on the right-hand side, we have x squared. We can bring all the terms to one side. Now we can factorize. And we solve for x. So x will equal negative 1 or 3. Now we can check our answers. So let's check x equals negative 1. We can substitute it back into the original equation, but it's going to be easier to substitute it back into this equation here before we squared it. So then the left-hand side will equal the square root of 2x plus 3. So 2 times negative 1 plus 3. And this equals the square root of 1, which of course is 1. Then the right-hand side is negative x, which is negative minus 1. And this, of course, is 1. So we can see that the left-hand side comes to the right-hand side, and hence x equals negative 1 is a valid answer. Let's now check x equals 3. So once again, substituting back into the left-hand side of this equation, before we squared it, the left-hand side is going to be the square root of 2 times 3 plus 3. And this is the square root of 9, which is 3. And the right-hand side here is negative x, and x is 3, so it's going to be negative 3. So we can see here that the left-hand side doesn't equal the right-hand side. So that means that x equals negative 1 is the only valid answer. So x equals negative 1 only. Let's look at your answers to this question. So in the first one, we have the square root of 5x minus 1 minus 2x equals negative 1. Now, we can start by taking the negative 2x to the right-hand side. So we only have the square root on the left-hand side. We want to get rid of the square root, so we square both sides. So squaring both sides. Then on the left-hand side, the square root falls away. And on the right-hand side, we can square out this binomial. So it's a first term squared, which is 1. Then this sign, so plus. Then the first term times the second term times 2. So twice negative 1 times 2x. And then plus the second term squared, so 4x squared. We can simplify. So that's 1 minus 4x plus 4x squared on the right-hand side. And we can bring everything to one side. So it's 4x squared. Then negative 4x minus 5x is minus 9x. And then of course we have 1 plus 1. So then plus 2, and this equals 0. So we have a quadratic and we can factorize it. So it's 4x times x, 2 times 1, and minuses in the brackets. And we find that x comes to a quarter, or 2. Now we need to check our answers. So let's first check x equals a quarter. And we're going to substitute a quarter in for x into the left-hand side of the original equation. And recall that the original equation was the square root of 5x minus 1 minus 2x equals negative 1. So then substituting x equals a quarter into the original, or into the left-hand side of the original, it's 5x less 1 less 2x. And we can use a calculator here. Under the square root we have 5 over 4 minus 4 over 4, which is a square root of a quarter, and this gives us a half. Then 2 times a quarter, 2 into 4 twice, so we're left with a half as well, and this equals 0. Now this doesn't come to the right hand side of negative 1, so this is not equal to the right hand side, and hence we know that x equals a quarter is not a valid answer. Let's check x equals 2. So x equals 2. Then substituting this into the left-hand side of the original equation, we have the left-hand side equals the square root of 5 times 2 minus 1 minus 2 times 2, or minus twice 2. And here we get 10 minus 1, which is 3, or rather 10 minus 1, which is 9, and the square root of 9, of course, is 3, and this is minus 4, and this comes to negative 1. Now, this is equal to the right-hand side of the original equation, so it equals the right-hand side, and hence the left-hand side equals the right-hand side, and we can conclude that x equals 2 only. Let's solve the second equation. So we have twice the square root of 25 minus x over 4 minus 1 equals 2x. We can start by taking the negative 1 to the right-hand side. So 2x plus 1 on the right-hand side. Now, we can divide by 2 to get rid of the 2 here in front of the square root, but we want to avoid fractions when necessary. So at this stage, we can square the whole of the left-hand side together with the right-hand side in order to eliminate the square root here. So then on the left-hand side, we're going to get 4. So 4 into 25 minus x over 4. In other words, the square root falls away on the left-hand side. And then squaring out the right-hand side, we get 4x squared plus 2x times 1 times 2, so plus 4x plus 1 squared. We can multiply the 4 into the brackets here, so it's 100. And 4 times x over 4, we're left with x because the 4's cancel. Now we can bring everything to one side. So 4x squared. Then 4x plus x will give us 5x. And 1 minus 100 is minus 99. And this is equal to 0. So we end up with a quadratic once again, which we can solve. In this case, we are forced to use the quadratic formula. And of course, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's substitute in our values of a, b, and c. Then x equals, so negative b, and b is positive 5, so it's negative 5 plus minus b squared minus 4 times a. A, of course, is 4. So 4ac, and c is negative 99. This is all over 2a. So 2 times 4. We can first work out under the square root, and it comes to 1609. This is all over 8. So then x is equal to, we can first work out negative 5 plus the square root of 1609 divided by 8, all divided by 8. So negative 5 plus the square root of 1609 and then divided by 8. And it's 4,39 rounded off to 2 decimal places. So 4,39. Or x equals negative 5 minus the square root of 1609 all divided by 8. So negative 5 minus the square root of 1609, and this is divided by 8. So minus 5,64. So these are the two answers we get for x, and now we need to check them by plugging them back into the original equation. So let's first check x equals 4,39. We're going to substitute this back into the left-hand side of the original equation. So then the left-hand side, now recall that the left-hand side was twice the square root of 24 minus x over 4 minus 1. So twice the square root of 25 minus 4,39 x over 4 minus 1. And this we can work out on a calculator. So twice the square root of 25 minus 4,39 over 4 minus 1. And it comes to 8,78. So 8,78. Then the right-hand side of the original equation was 2x. So it's going to be twice 4,39. And this also comes to 8,78. So we can see that the left-hand side equals the right-hand side. And hence, x equals 4,39 is a valid answer. Let's now check x equals negative 5,64. So we're going to substitute into the left-hand side of the original equation. So it's going to be twice the square root of 25 minus x over 4. So 25 plus 5,64 over 4 less 1. So let's see what this comes to. And it comes to 9,30 rounded to 2 decimal places. Then recall that the right-hand side of the equation was 2x. So 2x. So it's going to be 2 times negative 5,64. Which is negative 11,28. So negative 11,28. And clearly the left-hand side doesn't equal the right-hand side. And hence we can conclude that x equals 4,39 is the only valid answer. So therefore x equals 4,39 only. Let's look at number 3. So we have the square root of 75 minus 3 times the square root of 12 all over x. And this equals the square root of 48 divided by 2. Now, we're going to start by first simplifying the numerator on the left-hand side. Now, the square root of 75, we can write as a square root of 25 times 3. So 25 is the largest perfect square that goes into 25. And this is the square root of 25 times the square root of 3, which is 5 square root 3. So 5 square root 3. Then the square root of 12, the largest perfect square into 12 is 4. So we can write it as a square root of 4 times 3, which is a square root of 4 times the square root of 3. And this is twice the square root of 3. So twice the square root of 3. But of course we also have to multiply by the 3 here. So twice the square root of 3 times 3 is 6 times the square root of 3. Then we can simplify the square root of 48 in a similar way. The largest perfect square into 48 is 16, and it goes thrice. So we get the square root of 16 times the square root of 3. And this is 4 times the square root of 3. So 4 times the square root of 3 all over 2. So here we have 5 square root 3 minus 6 square root 3. And that's minus 1 square root 3. On the right hand side, 2 goes into 4 twice. And we're left with 2 times the square root of 3. We want to solve for x. So we can cross multiply x times twice square root 3 will give twice the square root of 3 times x, and 1 times the negative of the square root of 3 is minus the square root of 3. Now we can divide by 2 square root 3, and the right hand side will be minus square root 3 divided by twice the square root of 3. And this, of course, is negative a half. The square roots cancel here. So we end up with x equals negative a half. Now, note that in this equation, we didn't have to square both sides, so we don't have to check our answer. So x is simply equal to negative a half. Let's look at the last equation. We have the square root of x minus 2 plus 1 equals 6 over the square root of x minus 2. We're going to start by multiplying through by the LCD. So multiply through by the square root of x minus 2. Then on the left-hand side, the square root of x minus 2 times the square root of x minus 2 is just x minus 2. And of course here we are using the Surds law that says the square root of a times the square root of a is a. Then plus 1 times the square root of x minus 2. On the right hand side, the square root will cancel out here when we multiply by the LCD, and we're left with 6. We're going to take everything but the square root to the right hand side. So it's going to be 6 plus 2, which is 8. And then bringing the x to the right hand side, we're going to get negative x. Now we can square both sides in order to get rid of the square root. So then squaring the square root, it falls away. On the right hand side, we square out. So it's going to be 64 minus 16x plus x squared. Then bring everything to one side, x squared. Then negative 16x minus x is negative 17x. And 64 plus 2 will give us 66. This equals 0. We have a trinomial which we can factorize. So it's going to be 11 and 6. So then solving for x, we see that x equals 6 or x equals 11. So let's check our answers. We can first check x equals 6. We're going to substitute x equals 6 into the left-hand side of the original equation, which is the square root of x minus 2 plus 1. So the square root of x minus 2 plus 1. This is 6 minus 2, which is 4. Square rooted will give us 2. Plus 1 is 3. Then the right-hand side, recall that the right-hand side was 6 over the square root of x minus 2. So it's going to be 6 over the square root of 6 minus 2, x minus 2. And in the denominator here, we have the square root of 4, which is 2. And this is also equal to 3. So then the left-hand side equals the right-hand side. And we know that x equals 6 is a valid answer. Let's check x equals 11. So x equals 11. Then the left-hand side. We said the left-hand side was the square root of x minus 2 plus 1. So it's going to be the square root of 11 minus 2 plus 1. This is a square root of 9, which is 3, plus 1, which is 4. And the right-hand side was 6 over the square root of x minus 2. So it's going to be 6 over the square root of 11 minus 2. And, of course, 11 minus 2 is 9. Square rooted will give us 3. So it's 6 over 3. 6 over 3, which is 2. So in this case, the left-hand side doesn't equal the right-hand side. And hence, x equals 11 is not a valid answer. So the only answer then will be x equals 6. So then our final answer is x equals 6 only.